Okay, today we are taking a look at lesson 4. It is more to do with tape diagrams. We're going to look at a lot of equations today and solve some of them. And looking at our first problem, it says find the solution to each equation without writing anything down or solve it mentally. So would you please take a look at these 4 equations and find the solution for x? Now, hopefully what you found is that all 4 of these equations actually have the same solution. X equals 4. And starting with kind of the easiest one here, it's pretty easy to see that if we need to put in a value for this missing amount, x, we increase it by 1 to get 5, then we need to just decrease by 1 to get x. And kind of the same happens for a lot of these. These next 3 are just multiplication problems. 2 times something equals 10. Then we just have to adjust our missing factor by just a little bit to find what x is. And the same thing here. 3 times something equals 15, and 100 times something equals 500. All right? Moving along, now we're going to draw some tape diagrams. The first one says, and we'll underline the key information as we go here, Diego has 7 packs of markers. Each pack has X markers in it. After Lynn gives him 9 more markers, he has a total of 30 markers. So our tape diagrams follow a lot of the same ideas here. I always start them the same way and just draw that tape. The first thing I want to do to start is find the total if we're given that information. And we're told he has 30 markers. And then I just need to figure out how to divide it up. So he has 7 packs of markers. Each has an unknown amount, an X amount in it, and then Lynn gives him 9 more. So we need our 7 packs of markers. 1, 2, 3, 4, 5, 6, 7. They each have X markers in them. And Lynn gives him 9 more. All right, that would represent our situation there. And that's all we have to do for this part of the activity. So next, Elena cuts a 30-foot piece of ribbon. She cuts off 7 feet, and then cuts the remaining piece into 9 equal lengths of X feet each. So start with our tape. Find the total value of that tape, which is the 30-foot piece again. All right, so we're looking very similar to what we last did in part A. And cuts off 7 feet. So 7 feet is removed. I'm going to actually keep that here at the end. And the rest is cut into 9 equal lengths of X feet. 1, 2, 3, 4, 5, 6, 7, 8, 9. All of X feet in length. Okay, for the next 3, I'd like you to look at those, please. Remember to start by finding the key information in the problem, drawing your tape diagram, and then we'll compare our answers once you've done it. So for C, a construction manager weighs a bundle of 9 identical bricks and a 7-pound concrete block. The bundle weighs 30 pounds. So our total combined weight, again, is 30. We have 9 identical bricks, but that's what we don't know the weight of, so that's going to have to contain our variable there. We do know the weight of the concrete block, which is 7 pounds. So we have another 7-pound section here, 9 identical bricks. Just like that. Moving on to the next part. A skating rink charges a group rate of $9 plus a fee to rent each pair of skates. A fee to rent each pair is the thing we're not told. That's our variable. And a family rents 7 pairs of skates and pays a total of $30. So our total is what they paid, $30. Part of that fee is going to be $9 for the group rate, and then they rent 7 pairs of skates, which has an unknown cost. 1, 2, 3, 4, 5, 6, 7. All right, and then finally, Andre bakes 9 pans of brownies. He donates 7 pans to the school bake sale and keeps the rest to divide equally among his class of 30. All right. Well, for this one, if we draw it out, this time our total is not going to be 30. So if we look closely, our total is what he baked. He baked 9 pans of brownies. Now, we were told that he donated 7 pans. So, 7 pans is most of this tape diagram. So we'll try to make it kind of proportionate here, making this the bigger section. And now if he's taking what remains and equally dividing it among 30 students, and we're kind of representing what each student gets here, that means we should have 30 sections here with an X in each of them to represent what each student gets. But that's going to be a little crazy for a tape diagram. I don't want to try to divide this section into 30 pieces. So here's what we're going to do. We're going to abbreviate. And just like we could have done here, it's just not as well represented, as we can write 30X in our other portion of the tape diagram. So when our numbers get larger or even small and hard to represent, we can just use a notation like this. Instead of trying to show 30X's, we will just label that section 30X. Now, as we move into the next activity, this one had us match, let's see here, each situation in the previous activity is represented by one of the equations. Match each situation to an equation, find the solution to each equation, and use your diagrams to help you reason. Okay, so let's find all of the situations that match 7x plus 9 equals 30. 7x plus 9. So if we go back to A, we're looking for a diagram, of course, that has a value of 30, and most of them did. 7x plus 9, we have 7x's and 9, so A is definitely a match for that. This one has too many x's, but the other one that matched was D. So what we'd write here is A and D, and we need to find the solution. So if I were to take this equation, 7x plus 9 equals 30. Here I want to get rid of the plus 9 first, and you can see how I would want to do that in the diagram. I want to remove the part that I know so I can work on what I don't know. I'm going to remove 9 from the total, so I'm going to take it away from 30 also. And to do that, on our two sides of our equation, we'll remove 9, which will cancel this and leave us with 7x equals 21. Okay, now all we have to do is take that remaining total and divide it into the 7 groups, into the 7 x's equally. So we'll divide by 7, and our solution is going to be that 1x equals 3. Now, would you please look back at your diagrams for A through E, find the ones that match this equation, 30 equals 9x plus 7, write them down and then solve it. Now, hopefully what you found is that B and C had the same diagrams for that. If we had written them where the 7 was before the 9x's, that would be fine because we can interchange that. So if your drawings don't look exactly the same, that's okay. But when we solve this, we're going to do the same process again. We want to remove that extra 7, so we'll subtract 7 and balance it on each side. What we're left with once that cancels is 9x, and then remove 7 from 30 to equal 23. Okay, now I need to take the 23 and evenly distribute it to the 9x's. So I'm going to divide each side by 9. That will give me a value for x when I do 23 divided by 9 of, well, a couple of ways to represent it. I could just write 23 divided by 9, or I could write that as a decimal, which is not quite as good because it's a repeating decimal, so it'd be 2.5 repeating. But either way is going to represent that. And then finally, our only other situation, which does match this, because remember we changed the total to 9 on this last diagram here of the brownies. So that matches situation E. And when we solve this equation, do the inverse operation of adding 7. So we'll subtract 7 from each side. Then we're left with 30x equals 2. And now we just have to take those 2 pans of brownies and share it or split it among 30 people. So we're going to divide by 30, balance it over here, and that tells me that x equals, again, I could keep 2 divided by 30, but I could simplify that. Each of these numbers can be divided by 2, so that would be 1 divided by 15, 1/15. Each student is going to get 1/15 of a pan of brownies there. All right, finally, we've got a diagram, a tape diagram. We're going to find the solution to the equation and explain our reasoning. So, looking here, I kind of like solving them here with the tape diagrams because we can just see here, we need to eliminate this part of the diagram that we know. In an equation, what we would do is the inverse of adding 17 and balance each side so that that cancels out, and we're going to cancel 17 of the 23. 23 minus 17 leaves me with 6. 4x's equal 6. So really, if this helps you, what we're dealing with now is our 4x's, if we modified our tape diagram, is equal to 6. This is what we're trying to solve now. So we'll divide that total by the 4x's that are there. Do the same here. And 1x is going to be equal to 6/4. 6/4 can be written a lot of ways, but 1.5 or 1.5 is a really common way to show that. So that would be our solution. Each of these x values is worth 1.5. Combined with the 17, we'd have a total of 23 again. Okay, that's it. That's lesson 4. Please take a look at the practice problems for lesson 4. Do a really good job on those. If you have any questions about tape diagrams, about equations, let's talk, because starting next week, I think Tuesday, we're going to have a quiz coming up. Everybody have a great day.